So we've got a question here. We're going to find the point in which tangent x takes on its average value in the range of 0 to pi over 3. Now, tangent x, for the purpose of this question, is not continuous over the whole real numbers. There is pi over 2, for example, and minus pi over 2, where this function is not continuous. So here we've got 0 to pi over 3. We know it is continuous. So to find the average value, let's have a look at our generic way of finding the average value of all functions. So first of all, we have a function f of x, and we need to know that it's continuous. So I'll just write continuous like this on an interval a to b. That's the first thing we need to know. Okay, so next thing we need to know is what happens at the endpoints. So for that we can use the extreme value theorem. So extreme value theorem. Now here we'll assign m as our minimum value. So that's our minimum. And we'll have capital M as our extreme value, as our maximum value. So I'll just write minimum and maximum so we can see what they are. So by the extreme value theorem, our f of x is going to be larger than a minimum value, and it's going to be smaller than our maximum value. So that's our capital M. Okay, now we want to know over the range of these values for our f of x what the average value is. So by that, let's introduce the comparison theorem, which uses the integral of our f of x. So therefore, if we have our integral from a to b of f of x dx, so what we can use is the comparison theorem, which gives us b minus a times our capital M. And this function here, this integral, is always going to be less than this value. And it's always going to be greater than the minimum value with b minus a. Okay, so that's our comparison theorem. So let's just write that up here for us, comparison theorem. Okay, now what we can do is here, we can divide all terms by b minus a to get these extreme values on their own. So now let's divide all this by b minus a. And now we'll get our minimum value is always going to be less than or equal to 1 over b minus a, so I can bring that out. And integral from a to b of f of x dx. And this is always going to be less than or equal to maximum value. Okay, so now what we need now is something called the intermediate value theorem, just for a point C inside this value here. So if we have C is in the same range of a to b, in this case our question 0 to pi over 3, that's what our a and b will be. What we have now by the intermediate value theorem, just write this on here, just write this as intermediate. There is a point C, f of c, such that it equals 1 over b minus a, and the integral from a to b of the function f of x dx. So the integral of that. So f of c will always be a point in there. Okay, so we're going to use this to find our average value of our tangent x. So let's underline that, from 0 to pi over 3 using this formula. So what I'm going to do now, I'm going to clear this off the board, and then what we're going to do is going to try and calculate our average value for the function. Okay, so now let's use this to try and find our average value. Got a bit of space to work on. Let's go through it. Okay, so we've got our range A to B, which is from 0 to pi over 3. So let's just write these parameters down on here. 0 is A and B is pi over 3. Okay, let's go straight into this. So we've got f of c equals 1 over b minus a, so that's pi over 3 minus 0. And then the integral from a to b, which is 0 to pi over 3, of our function, which is tangent x, and then integrated with regards to x. Okay, let's go through the steps and we can integrate this straightforward from tangent x. So that's a standard integral. So now we've got 1 over pi over 3. And then tangent x, now the integral of that, the standard integral of that, is negative natural logarithm of the absolute value of cosine x. So that's the integral taken care of. And the range is from 0 to pi over 3. Okay. Now, negative log of cosine of x, I prefer to write that a little bit differently. Now, using the logarithm rules, if I've got negative natural log of, let's say for example, I have k over t, I can rewrite this with this minus sign. I can write that now as the natural log of t over k. So that way then I can get rid of this minus sign by flipping it. Now here I can do the same here. Now if I have cosine x over 1, using this example, I can then flip it and get 1 over cosine of x, which is the same as secant x. And then that way then I can get rid of the minus sign in this natural logarithm. So I'm going to rewrite this in terms of secant x. So now 1 over pi over 3, I can rewrite that as 3 over pi. And then my result of my integral now, instead of negative log, I'm going to have positive log. That's also the natural logarithm of secant x. So we'll remember to put in the absolute value. And then that is calculated from 0 to pi over 3. Okay, let's go straight in and calculate this out. So now we've got 3 over pi multiplied by the log of secant x. So secant of pi over 3, or cosine of pi over 3 is a half. So therefore secant of pi over 3 is going to be 2. So now I've got log of 2. And then at 0, I've got cosine of 0 is 1. So therefore secant at 0 is also going to be 1. So that takes care of those values. So no need for the absolute value here, because I know that this is a 1. These values here are all positive. Okay, well, log of 1 is 0, so that cancels out. So now I'm just left with a log of 2. So now I've got 3 ln 2 over pi. Now, what I do know here by log properties as well, if I just write another one here. So I've got, use my t and my k again. So if I've got t ln k, I could also write this as ln of k to the power of t. That is the same identity. So here I can bring my 2 to the power of 3. So 2 to the power of 3 is 8. So therefore, if I just write that here, 2 to the power of 3 is 8. So 3 ln 2 is the same as natural log of 8. So natural log of 8 over pi. Okay, so that's what my value is at my point C. So f of C equals natural log of 8 over pi. Okay, now let's clear this off the board and let's calculate the final part of the answer to find the average value of tangent x over this point. Okay, let's clear this off. Okay, so now we've got f of c equals ln 8 over pi. Now our function here is tangent x. So now I've got tangent of c equals natural log of 8 over pi. So now what I want to do to get my point C on its own, I will now take the inverse tangent of both sides. So inverse tangent, let's just do that of the whole thing. So now I'll get C equals inverse tangent of natural log of 8 over pi. Okay, now natural log of 8 over pi, let's just have a look at that. ln 8 over pi, that is approximately 2.079. So if I just keep going like that, I can leave it as an equal sign. And then divided by pi, then plugging that into my calculator right from this point, I'll get approximately 0.6619. And keep going on and on. Okay, so now I want the inverse tangent of 0.6619. So if, let's just put this in a box here. So therefore then my C will be approximately 0.5847. And it will keep going on and on. So that's the point in which tangent x has its average value at the point C equals 0.5847. Okay.